Welcome. Today, we're diving into the essential elements that bring technical drawings to life. A drawing is more than just lines, arcs, and circles. It's a language, a precise form of communication used in engineering, architecture, and manufacturing. The geometry alone tells us the shape of an object, but how do we convey its size, the material it's made from, or how it should be assembled? This is where annotations come in. Think of elements like dimensions, hatching, notes, and the focus of our discussion, multi-leaders, as the grammar and vocabulary of this visual language. They transform abstract geometry into a comprehensive set of instructions. These annotations provide layers of critical information, clarifying materials, manufacturing processes, required tolerances, and specific components. A well-annotated drawing ensures that the person on the shop floor or the construction site has all the information they need to turn the design into a reality exactly as the designer intended. Without these crucial elements, a technical drawing would be incomplete, ambiguous, and ultimately useless. Throughout this presentation, we will explore each of these components to understand how they contribute to creating clear, professional, and effective documentation. Let's break down what we mean by annotations. It's a broad term that covers several distinct types of informational graphics. First, we have general notes. These often appear in a dedicated area of the drawing and provide overarching instructions such as break all sharp edges R0.5 max or all fillets and rounds R2 unless otherwise specified. Next are labels and callouts, which are more specific. A label might identify a part with its designated number, like item 3 bracket, while a callout might point to a specific feature to provide a detailed instruction like tap M6.0 through. Then we have symbols. These are standardized graphics that convey complex information efficiently. Think of welding symbols, surface finish symbols, or geometric dimensioning and tolerancing feature control frames. They pack a huge amount of data in a small, universally understood icon. Finally, an important but often overlooked type of annotation is the revision element. Revision clouds, triangles with numbers, and revision history tables are crucial for document control, allowing everyone on the project to quickly see what has changed between different versions of the drawing. Each of these annotation types plays a vital role in removing ambiguity and ensuring the design intent is perfectly clear. If annotations are the words, dimensions are the numbers that form the backbone of any technical drawing. They provide the precise, measurable data that defines an object's size and the location of its features. A dimension is more than just a number. It's a system composed of several parts. We have extension lines, which extend from the feature being measured without touching it. The dimension line, typically with arrowheads at each end, runs between the extension lines and indicates the direction and extent of the measurement. And of course, there's the numerical value itself. Creating a readable and effective drawing requires adhering to strict dimensioning best practices. One of the cardinal rules is to avoid duplication. Stating the same dimension in multiple views clutters the drawing and creates a risk of error if the design changes and only one instance is updated. Another key practice is to always dimension to visible lines, not hidden lines, as this is far less confusing to interpret. Finally, maintaining consistent spacing between dimensions and the object is not just about aesthetics. It creates a visual rhythm that makes the drawing significantly easier to read and understand. Proper dimensioning is a skill that separates a novice from a professional drafter. When we need to show the internal features of a complex part, we create what's called a section view, which is like slicing the object open to see inside. But how do we visually represent the areas that were cut? The answer is hatching. Hatching is a pattern of lines or shapes applied to an area to indicate that it is a solid material that has been cut through in a sectional view. It's a powerful graphic tool that immediately communicates form and substance. More than that, specific hatching patterns are standardized to represent different types of materials. For example, the ANSI 31 pattern of single, evenly spaced diagonal lines is universally recognized as the symbol of steel. A cross hatch pattern might represent brass or bronze, while a sand-like stipple represents concrete. The visual properties of this hatching can be precisely controlled. The scale determines the density of the pattern, how close the lines are to each other. The angle allows you to rotate the pattern, which is especially useful when adjacent parts in an assembly need to be distinguished. Transparency can also be applied to allow underlying geometry to be seen. When used correctly, hatching provides instant clarity, allowing anyone reading the drawing to understand the form and material composition of the object at a glance.
Now we arrive at the star of our show, the multi-leader. In modern CAD software, the multi-leader, often accessed with the command ML-leader, is the intelligent and highly efficient tool for creating labels and callouts. At its core, a multi-leader is an object that consists of an arrowhead, a leader line, and some form of content, which can be text, a block with attributes, or a geometric tolerance frame. Its purpose is to create a clear visual connection between an annotation and the specific feature on the drawing it refers to. What makes the multi-leader so powerful is that it is a style-based object. This means you don't have to worry about drawing a line, adding an arrowhead, and creating a piece of text as three separate entities. Instead, you define a multi-leader style that controls every aspect of its appearance, from the arrowhead size and type, to the text font and height, to the presence of a landing line. Once the style is set, every multi-leader you create with that style will be perfectly consistent. This not only saves an enormous amount of time, but also enforces drawing standards, ensuring a professional and uniform look across all your documentation. It's a huge leap in efficiency compared to the old manual methods. The true power of multi-leaders lies in their deep customizability through the Style Manager. Let's look at what you can control. In the Leader Format tab, you can define the arrowhead, choosing from dozens of options like a closed filled arrow, a dot, an architectural tick, or even no arrowhead at all. You can also set its size. In the Leader Structure tab, you control the behavior of the line itself, such as the number of vertices it can have and the angle of its segments. This is also where you set the landing, which is the small horizontal line that the text sits on, and you can specify its length. The Content tab is where you define what the leader points to. You can set the text style, height, and color, and choose whether to enclose it in a frame like a box or a circle. Two advanced features are game changers. The first is annotative scaling. By making a style annotative, you ensure the multi-leader automatically adjusts its size based on the scale of the viewport it's displayed in. This means your text and arrows will always be readable whether you're looking at the entire building or zoomed into a tiny detail. The second is the ability to add and remove multiple leader lines from a single multi-leader note, which is perfect for calling out several identical items with one clean annotation. With a solid understanding of how to create and customize them, let's explore where multi-leaders are used in the real world. Their versatility makes them indispensable across all disciplines. In mechanical design, they are constantly used for component labels in assembly drawings, pointing to a bolt, washer, or bracket and labeling it with an item number that corresponds to a parts list. Material callouts are another common use. A leader can point to a cross-sectioned area to specify the material, such as 6061-T6 aluminium. In architecture, multi-leaders are the standard for creating detail references. A circular bubble containing a number and a sheet reference can be attached to a leader, directing the viewer to a magnified detail view on another drawing sheet. They are also perfect for attaching specialized symbols directly to a feature. A multi-leader can point to a machined surface and have a standard surface finish symbol as its content, or it can point to a joint between two parts and display a complex welding symbol. They can even contain dynamic fields that link to an object's properties, so the annotation updates automatically if the object changes. From simple labels to complex data-rich symbols, multi-leaders are the go-to tool for connecting information to geometry. To conclude, let's summarize the best practices that tie all these concepts together to create truly professional documentation. First, always use proper layer management. Place your dimensions, text, and other annotations on their own dedicated layers separate from the main geometry. This allows you to easily control their visibility, color, or line weight, and you can even turn them all off to see the clean geometry underneath. Second, embrace annotative scaling. It may seem complex at first, but taking the time to set up annotative styles for your text, dimensions, and multi-leaders will save you countless hours and ensure your drawings are perfectly readable at any plotted scale. Third, think about visual hierarchy. Use different text styles or sizes to distinguish between primary information like a part number and secondary information like a manufacturing note. This guides the viewer's eye and helps them process the information more efficiently. Finally, always prioritize coordinated placement and avoid clutter. Leave adequate space between dimensions and ensure leader lines don't cross unnecessarily. By mastering these tools, dimensions, hatching, and especially multi-leaders, and combining them with these best practices, you elevate your work. You move from simply creating a drawing to engineering a clear, concise, and unambiguous piece of technical communication, which is the ultimate goal in any design field.